And we're getting ready to live stream. Hi, everybody who's joining us so far. Welcome. Hi, Phil. Today we're going to be talking about Messier and his objects. There we go. We're up on YouTube. We've had a request to keep an eye on YouTube chat a little bit more, so I'm going to do my best to keep an eye on both. And we will go through today doing our best to take questions from everywhere that we can. Hello again from Midland. Hello, everybody. Thank you all for joining, especially those of you who join us multiple times. It's really nice to see familiar names in our chat and see you all coming back and over again. It's great.
All right. Let's start
okay.
sharing.
Oh, Katrina. Okay. Sorry, Katrina. Well, we have now made that change. So we have heard your cries. So I'll do my best to keep an eye on both. So today we are going to be talking about Messier objects. This time we're going to be talking about who Messier is, NGC objects, deep sky objects, how to work with them in Stellarium, all that sort of stuff. Chris is going to take us through it all. Thank you again, Chris, for being the knower of all things.
I'm not the knower of all things, but we're all learning, right? We're all learning.
Yes, absolutely. So today, Chris, what do you have to share with us?
Yeah, so I'm actually going to wind the clock back. We're going to go back. Observational astronomy with the telescope began in the early 1600s with Galileo, and then by the middle of the 1600s, we had Isaac Newton coming into the picture, and he started working with optics, and he created his Newtonian reflector telescope, and that's what you might have in your living room as a Dobsonian telescope. It's a Newtonian style reflector. And as more and more people began to get access to these instruments, they could start doing more science in the sky. And one of the things that intrigued people in the early days were comets. And I know that comets are not deep sky objects. I'm going to get into what deep sky objects means in a couple minutes, but just to set the stage a little bit. So around the time of Isaac Newton, and then following Isaac Newton, this gentleman, Edmund Halley, came into the picture in England. And, these were intellectual people. They were interested in science and mathematics and astronomy and all of that. And once Newton created his laws of motion and his theories of gravitation, and then Kepler came along and created the laws of planetary motion, people began to understand what makes things in the solar system move across the stars. And so it became all the rage to calculate the orbits. And comets were these naturally intriguing things that would come into the sky for a brief period of time and then leave the scene. And if you were able to spot a comet and work out its orbit, you got the honor of naming it. So it gets, named after you. So right around the sort of late 1600s, early 1700s or so, Edmund Halley started working. He even went and visited Newton and got, they sort of traded notes with each other and worked out the mathematics. And so Halley went off and started calculating the orbits of comets based on the published observations of some of the astronomers of the day. And when he did that, he started noticing that one comet, or one common set of orbital elements, were coming forth from a series of comet observations that were separated by about 76 years. So he took the comet that appeared in 1607 and the comet that appeared in 1682, and he worked out that this must be the same comet coming back on a returning cycle. So that was a periodic comet. And he predicted that would come back in 1758. Now he died before it could come back because he was getting to be on in age. But a young gentleman in Paris by the name of Charles Messier, he was a young guy, he was just getting into astronomy. He got a job at the observatory in Paris, and he was assigned to hunt down the comet. So all the astronomers and comet hunters in the world were on the lookout for the return of Halley's comet. So it wasn't really called Halley's comet until later when he predicted it to come back. And then when it did come back, then they could confirm that it was that he was right, and sort of give him that posthumous honor of naming the comet after him. So young Charles was scanning the skies and looking for Halley's Comet. And unfortunately for him, someone had steered him a bit astray and not given him exactly the right place to look. And so he got scooped. So an astronomer in Germany actually saw it first. And the other thing that happened is that its arrival was delayed a bit. And we think now that it was delayed by an interaction by Jupiter. So the Jupiter has such a mass of gravity that as Halley's Comet got near Jupiter, its orbit was perturbed. And so it was delayed in its arrival. So Halley's calculations hadn't accounted for that. So let me just look at my notes here so I get the story right here. Yeah. So he started looking in 1758, but he actually saw it on January 21st of 1759. And he sort of reported to the powers that be, because what you would do in those days is you'd write a letter and you'd send it to the Astronomy Society or the Physics Society, and then they would publish your results. But he got scooped by an astronomer in Germany, so he missed out. But don't feel sorry for Messier, because he got hooked. He then devoted his life to searching for comets. And he ultimately, I think, discovered about 16 at the end of the day.
Wow.
And what he would do, and what he and many astronomers would do, is scan the sky systematically. And because comets get brighter and more visible when they're nearer to the sun, because when they're nearer to the sun, they're warming up and they're outgassing and they're becoming brighter, they're sprouting tails and so on. So really what you wanted to do was hunt sort of near the horizon after sunset or near the horizon before sunrise, because then you were more likely to see the comet in that patch of the sky. And the unique thing about comets is that they move. You know, the stars are fixed in place, that's why we can make star maps, because the stars are all at known fixed locations. And if you were scanning the sky with your telescope and you saw a sort of a dim fuzzy cloud, then you'd look, then you'd maybe wait a few hours, look again, or come back the next night and see if you could see it again. And if it's moved position compared to the stars, then you knew you had a comet on your hands. And what you would do is you'd carefully note its coordinates in the sky. And after you've acquired enough observations, then you could work out its orbit and determine, you know, its orbital elements and things like that. Now, the problem was that people like Messier would be scanning the skies for these comets, and they would find a fuzzy patch, and they'd come back and look later, and it was still in the same spot. And they'd go, oh, fooled. There's this so-called, they used to call them nebulas in the sky. And the nebulas could look sort of bright, sort of star-like, you know, sort of starry, or they could be amorphous and gray, sort of gray globs. But they were sort of just, in their limited telescopes of the day, they were basically sort of fuzzy patches in the sky. And so I just want to get this story here right. So Messier decided that he was tired of being fooled by these imposters, these imposter comets. And so he would start recording where they were. And the star atlases of the day, many of them didn't include these fuzzy patches in the sky that we now know are so-called deep sky objects. And so deep sky objects would include nebulas, star clusters, and even distant galaxies, as we talked about on Tuesday. And so the very first object in Messier's list was over here near where Venus is right now. This is the sky tonight. And he was scanning the sky up near this star, Elnath. I'm just going to put on the... So here we've got the triangular face of Taurus the bull, and then two stars up here form the tips of the bull's horns. And up near this star, Messier thought he found a comet. And he would look again the following night, it didn't move, and it turned out to be what we know today as the Crab Nebula. And so the Crab Nebula got added to what he decided to do was create a catalog or an index of these annoying objects, and this became Messier #1, the Crab Nebula. Now, the Crab Nebula is not an easy object for you or I to see, especially near a big city, because it's fairly diffuse and quite faint. But in those days, in the sort of mid 1700s in Paris, the sky was a lot darker than it is, around one of Canada's big cities today. So he was able to pick it up even with his sort of modest, roughly about a 4-inch aperture telescope that he was using. So he noted it down and he kept on his searching. And whenever he would come across one of these weird little fuzzy objects, he would note it. He would make some comments about it. And eventually the other friendly competitors for comet hunting of the day, they started to pool their resources and pool their notes. And so Messier became kind of a person to collate all this information and build these lists up. So by about 1771, he'd collected about 45 objects, including their coordinates and what they looked like to him. And he got it published by the French Academy of Sciences. He had other helpers, the other people that were helping him. You might run into these names when you do a little bit of reading about Messier or about deep sky objects. Pierre Méchain, Barnabas Oriani, and Nicolas Louis de Lacaille. And so they would put their list, their ideas into the list as well. And eventually by about 1784, they had 103 objects in their list. And so those objects would include things that you've seen in the sky, I'm sure, if you've looked at the Pleiades star cluster. So the Pleiades star cluster in Taurus, which is near Taurus, which is, let's wind this back. We talked about the Pleiades last month.
Yeah, that was the one where Venus went. And
yeah, the one where Venus went through. That's Messier 45. And then if you ever got a chance to look at the Orion Nebula this winter, that's Messier 42. And so when you see when you're using an astronomy app or a star catalog or a sky catalog, and you see that the code M something, the M stands for Messier. So as I said, they came up with about 103 objects in their published list. And then over the ensuing several hundred years, as people started to do more of these observations, we actually added to this list, and we put another 7 objects in his list. And the justification for that was that modern astronomers had found Messier's notes and found objects that should have been there that were never added, either because Messier didn't confirm them or for whatever reason. So they thought he must have meant to have them in there, so we'll add them in there. And the other interesting thing, Jen and I were talking before the broadcast started, that there are lots of things in the sky, lots of so-called objects in the sky that you think would be Messier objects, but they're not. And it's a bit of fun to go off and read about why some very obvious fuzzy patches that we now know as a star cluster or a galaxy didn't get included in his list. Who knows? It's a bit hard to say.
All these probably politics back in the day, or missing them. Who knows?
Yeah. Now, just to sort of wind time forward a little bit, around you just want to get into the time here. So moving ahead into the sort of 19th century, we get a gentleman by the name of William Herschel, and he had a sister named Caroline. And William Herschel actually became quite adept at building large telescopes, and he built a big 20-inch diameter telescope, or 20 feet long, but it was a big mirror. I think it was about 20 inches in diameter. He set it up in his garden in England, and he decided that he was going to search the sky, but he was actually cataloging double stars. And he too was stumbling upon these sort of fuzzy objects. And by that point in time, people still did not know what they were. They just knew that they looked unusual, these deep sky objects, but they didn't understand what they meant, how far away they were, and what they are. And in a minute or two, I'm going to sort of run down the various families of deep sky objects that we're talking about. So William Herschel did a search. Let me just get my notes here. He searched for, let me get it here. Yeah, in the late 19th century, he published ultimately about 2,500 additional deep sky objects. And then Caroline had discovered some of them on her own, doing her own independent sweeps. And then after William's passing, well, even just before William's passing, his son took one of the big telescopes that they had constructed and took it to the southern hemisphere, where they then picked up another more than 1,000 more of these objects. Yeah.
So on that note, are all Messier objects, well, some of them will be visible from the southern hemisphere, but he was observing from Paris, so they're all objects that are visible from Paris.
Yeah, so every object in the Messier catalog would be visible from the latitude of Paris at one time or another of the year. You know, there are certain times of the year when you have to wait for something to arrive.
Right, yeah.
That's true. So yes, there was a whole slew of these objects that were not observable from mid-northern latitude. So it waited until astronomers started to take the tools of the trade to the southern hemisphere. So John Herschel took his telescope to Cape Town, South Africa, set up for a while there, and generated a wider catalog. And then around the sort of late 1800s, early 1900s, a gentleman by the name of Dreyer decided that he would go through and sort of confirm or redo the catalog. And he actually produced a catalog which at this point is now up to 7,840 objects.
Wow.
And he called that catalog the New General Catalog. And that's what the term NGC stands for, is the New General Catalog. So the New General Catalog was based on William and Caroline and John Herschel's searches of the sky. And they would do systematic sweeps of the sky, sort of go across left to right on a patch of sky, and then lift the telescope, go back left to right. And every time he found an object, he would note its coordinates with respect to a nearby known star. And he did more than 1,000 of these sweeps of these observing campaigns, William Herschel himself.
Wow.
So now we have this New General Catalog with 7,840 objects. It's not perfect. There's lots of sort of duplication in there, not lots, but there are a number of objects that are duplicated in there. There are some that are arguable. You know, sometimes you get a written transcription error, and maybe you've got, you know, the degrees and minutes written down wrong. So there have been cases where even in Messier's list, where people looked where Messier noted there was an object, they didn't find one, but if they sort of flipped the numbers around, they could find an object elsewhere that was maybe nearby that should. So the hypothesis was this is what he meant.
Interesting. Also, just since you have the Orion Nebula up, it is both M42 and NGC 1976.
Yeah, you can see that. Yeah. So the Herschels and Dreyer, they did not say, well, since Messier got it, I'm going to ignore that. They were trying to be systematic and scientific about it and map the entire sky the best they could to pick up every object, every such so-called deep sky object that they could. Now, if you have an astronomy app like Sky Safari or maybe Stellarium, and you look at the search menu, you might notice that there's also a set of objects in there called the Caldwell objects. And the Caldwell objects were actually created by an astronomer, a famous British astronomer by the name of Patrick Moore. And Patrick Moore did, he was like weekly astronomy on TV. He was a big popularizer in astronomy. He just passed a few years ago. And he decided that because Messier had missed out on a lot of these objects, that maybe he should create his own list and highlight some of the gaps in the list. And the other thing you should make note of is that in many ways, the Messier objects are what amateur astronomers and beginning astronomers call the showpieces of the sky. So they include many spectacular objects that are really the first things you want to look at once you've sort of finished with the moon and the planets and that kind of thing. So Caldwell said, no, we want to pick up the gaps that Messier missed. So I'm going to create another 110 objects. And because my name is Moore, I can't call them M objects. So I'm going to name them after my mother's name. Her name was Caldwell. So he called them the Caldwell list. And so you might see in Sky Safari, there's the Caldwell objects. There's 110. But he decided to include the entire celestial globe from the North Celestial Pole to the South Celestial Pole. And I'll use Stellarium in a minute and I'll show you where they are. So number 1 is closest to Polaris and number 110 will be closest to the south celestial pole in octans of the southern hemisphere. And so if one of your missions is to see and view all the Caldwell objects, you have to visit the southern hemisphere with a telescope and spend some time down there.
If astronomers like anything, it is trips that allow them to go other fancy places. And so I bet you there will be a lot of people taking you up on that kind of challenge.
Exactly. All right, so let's break down quickly what deep sky objects are. So deep sky objects, a good rule of thumb definition for them would be anything that's either stars or gas and that is not a single or a double star. So you can get multiple star systems being considered deep sky objects. And then of course you can go up from there, and star clusters and nebulas and galaxies are all considered to be what we call deep sky objects. And of course they're except for galaxies, all the deep sky objects are parts of our own galaxy. So they're in our own Milky Way. The only ones that aren't inside our Milky Way or associated close to it are the other galaxies altogether, as we sort of touched on the other day. So let's just run down what we've got in the way of deep sky objects. Now, if you're using Stellarium, if you go into the sky and viewing options number F4, and you head on over to the tab that says DSO, you can see here that you've got a list of all of these boxes with abbreviations, and you can toggle them on and off. And you can see that you're now going to pick up on some of what I've been saying. So the M objects, I want to see the M objects, so you make sure there's a check mark there. If you want to see the Caldwell objects, then you put a check mark in the C. If you want to see the NGC objects, and again, there's overlap between some of these, you want that enabled. And the IC objects are an additional catalog of even more objects that Dreyer put together after he finished the NGC, New General Catalog. The other ones in here tend to be specialty classifications. So for example, this astronomer named Halton Arp, he noticed that some galaxies are twisted or warped, or maybe they're merging. And he thought that those peculiar looking galaxies should have their own list. So the ARP would be considered the galaxies that are peculiar.
We had some questions about that last time. So anybody who had questions about interacting galaxies, that sort of stuff, that would be a good one for them.
Yeah. Now, the other way you can work with Stellarium, there's a couple other things that you can play with here. Now, down here, you've got labels and markers. So this will show a label and a symbol for the deep sky object. And then you can control how many of them are shown in the sky by hitting these sliders. And the bright ones, the brightest only would be at this end of the scale, and then every single possible one would be the dimmer ones. So you can make your sky chart really complicated by pulling these sliders up, or keep it sort of simple. And the ones that you're most likely to see in, say, binoculars or a small aperture telescope would be the ones, you know, down at this end of the range. So if you don't want to confuse yourself and you just want to say, what am I likely to be able to see on my dark sky night? You can do that. You can pull it down and set it for that. Okay. The other thing that you might want to check in Stellarium is this use proportional hints. And what you can see is that an object that's really easy to see will get a bigger symbol. So this is sort of doing a bit of sorting for you. See, if you want to know what's the easiest one to see in the sky, well, it's this one called the Pleiades. And down here, the Orion Nebula's got the big big yellow dotted circle. Okay. Now, what I'm going to do is I'm going to actually put on this filter by type. I'm going to turn off all these and put them on one at a time, because I want to show you what we can do with this. And I'm going to wind back. Also, I want to make the sky darker, so I'm going to set the time to at least 10 o'clock. Maybe I'll go to 11 o'clock just to make it nice and dark. Put that away. Now, well, if you tuned in on Tuesday, you know that the Milky Way is not really up in the sky this time of the year, because the orientation of our solar system and the Earth's axis of rotation tends to put the Milky Way along the horizon in spring. So what I'm going to do is I'm actually going to advance the date and put us into the summer, just for sort of illustration purposes. So here we are in July. And I'm just going to orient this here like this. And I'm going to make the Milky Way a little brighter. If you go onto the sky tab, you can click here and you can make the Milky Way brighter, just so it's a little more obvious.
It'd be great if we had these controls in real life.
Yeah. Turn off light pollution. By the way, I meant to say the other day, two things. One is that because of the social distancing, amateur astronomers can't really drive to their favorite dark sky locations right now. And so I'm appealing to everybody, if they can, to turn off their lights outside at night. If it's a clear night. If it's a cloudy night, I don't care. Or if it's a full moon, I don't really care. But if it's a nice dark new moon night, like the Lyra meteor showers, turn off your lights if you can, at least, you know, until midnight or something, just to give astronomers or people that have their backyard telescopes out a chance to see some of the objects that they might not be able to see from the city normally. So if everybody just does their part.
I will briefly mention, if you want to try out the difference in light pollution, if you can go and out to an area where there are streetlights and look up at the sky, even doing something as simple as blocking the streetlight from your view makes a huge difference on what you can see. So you can imagine the kind of difference that actually turning off the lights would make. And it is incredible. It's so sad that, you know, most of the people who live in Toronto have never seen the Milky Way before. And so it would give I agree with you, Chris, it would give everybody an opportunity to see something that would be a little, you know, unique at a time like this.
Yeah. The other thing that I should have mentioned, that I hope I was clear the other day, but I might not have been on Tuesday when I was talking about galaxies and how to see them, is that I mentioned that it's galaxy season, and that during the new moon, during galaxy season, is your best opportunity to see them. This is not the only week that we can do that. So in about 3 weeks' time, when the moon gets to its last quarter phase, we'll get another week or two of nice dark skies where the galaxies will still be up in the sky and visible for us. So if you don't get some good weather, some good skies during this week's new moon period, then just wait a few weeks for you know, mid-late May, and you have another chance at it. All right, so what I've done here is I've got the Milky Way. I've got this, basically the summer evening sky, and I'm just using this sort of time of year just to explain to you the difference, but some of the deep sky objects are. So the first one I want to talk about are open star clusters. So I'm just going to down on my filter by type and put on the symbols for the open star clusters, and I'm going to crank them up. Hints.
Oh, wow.
I'm just going to turn off the labels so you can see where they are. So open star clusters are essentially families of stars that have relatively recently, I mean astronomically, formed as a collective out of the common, you know, hydrogen cloud or gas cloud. So they tend to be distributed along the Milky Way because they're actually formed inside the plane of our galaxy. So most of the open clusters you see in the sky are going to be found somewhere kind of along the trace of the plane of our Milky Way galaxy. Because we live in a three-dimensional object that's a galaxy, you will find some that are away from the plane because you're just basically looking up or below the plane of our galaxy. Now, the open clusters can be large in the sky if they're near to us, or relatively tiny and faint if they're far away from us. And I'm just going to bring you up a picture of an open cluster. Let me see if I can do this here.
I will leave my question.
Sorry, go ahead.
Never mind. It was all good. I had a question, then I realized you've already answered it, so it's okay.
Yeah. So this was a question from one of our missions to our scavenger hunts, our astro scavenger hunts. This is that ET or Dragonfly Nebula, Dragonfly cluster, and this is an open cluster, and generally speaking, the number of stars can be hundreds to dozens to hundreds to thousands of stars, depending on how big the cloud was that made it and how far away they are, and have they been dispersed or are they still traveling together. And oftentimes you'll see sort of stars that don't look like the others. And in many cases, that's because these are not part of the cluster. They're in the foreground. So they're closer and so they're brighter. So you'll find situations where, you'll have a beautiful cluster of stars, and then maybe they'll all be sort of a blue-white color, but then there'll be a wonderful golden star that's in the corner of it or something. And often that's an unrelated star that's in the foreground. So that's what makes finding these deep sky objects really interesting. So the triangular face of Taurus that I showed you, that's one of the closest open star clusters to Earth. That's the Hyades star cluster. And the Pleiades is another one. That's why it's fairly large. It's not as close as the Hyades. And then something like that ET or Dragonfly cluster would be much farther away. So if you just take your binoculars on a clear night, moonless night, and just scan along the Milky Way, you're going to see these little bright knots of stars. And those are star clusters that you're finding as you do that. Now, as opposed to globular star clusters. So in Stellarium, the open star clusters are the dotted yellow circles. And the globular clusters are solid circles with excess through them. So in that picture I just showed you, the open star cluster is this one. This is a globular star cluster. So globular star cluster is a collection of maybe hundreds of thousands or a million stars that are sort of in a spherical clump due to their mutual gravitational attraction. And these objects tend not to be inside our galaxy, but they tend to orbit around the outside of our galaxy. And I mentioned on Tuesday that, one theory is that maybe that those are former mini galaxies that have had their dust and gas stripped out of them and just left their stellar cores. These objects tend to be, let me just go back to my notes here. So globular clusters can be anywhere from, 15,000 light years away, but because they're physically outside our galaxy, they can be 100,000 light years away. I mean, they can be quite a distance. So these are the globular clusters. So that's why you're seeing them not collected quite so neatly against the axis of the galaxy here. All right. So those are star, deep sky objects made of stars, but what about ones made of gas? So let's turn on hydrogen regions. So Stellarium uses green boxes to outline places where there's collections of hydrogen gas in the galaxy. When you look at Hubble Space Telescope images of galaxies, you'll see those pink knots inside the spiral arms, and those are glowing gas clouds of hydrogen. So if I take one here near the teapot of Sagittarius and zoom in on a little bit. And this is Messier 8. I'm just get rid of my zoom control here. So this is the Lagoon Nebula. And you can see that the red color is produced by energized ionized hydrogen gas, which glows with a red color. So that one's going to be visible come the summertime. There's another one. Here's another one that you can see in binoculars from a dark sky on a moonless night. And this is called the North America Nebula. I don't know if you can see the shape of it. So this is sort of Mexico. Here's the Gulf of Mexico. Florida would be here. And they kind of a wedge-shaped North America, US and Canada. We're up here somewhere shape. The other thing that you'll notice in here is that there's a dark patch. And this is all probably one and the same cloud of hydrogen. But the separation here is because of opaque dust in the foreground that it makes it the two lobes separate from each other. So we actually have different names for these. This is the, let me just wind back here and grab. This is the Pelican Nebula. I guess in some photos it sort of resembles the shape of a pelican. So those pink clouds, those are the hydrogen gas clouds. Let me see if I can find another one here. Bright Nebula. So Stellarium, there's really two sort of sets, but they're kind of the same thing. Bright Nebula, Hydrogen Nebula. And those will be sort of characterized by those pink colors. Now, if I go back, I just want to go back to Orion for a second. So let me just go back to today. I'll go back into March so we can see Orion a little bit better here. So if you look at a picture of the Orion Nebula, you're going to see that you've got that glowing pink, that's the hydrogen glowing. You're going to see some darker sections to it. That's probably intervening dust that's sort of separating the lobes of the gas. And then you're also going to see these sort of blue halos around some of the stars. And that's what these sort of bright nebulas are. So the bright nebulas would be more things like, we call their pink ones emission nebulas, and we call the bluish ones reflection nebulas. And what's happening is that the light from the stars is reflecting or scattering off dust and gas that's enveloping them, and it scatters preferentially with a blue light. So in an astrophoto, you'll see sort of these blue halos. So you've got emission nebula, reflection nebula. So if you see blue color, it's reflection. If I go up here to Orion's belt and zoom in on Alnitak, you can see that we've got the Horsehead Nebula is an emission nebula. And then we've got reflection nebula here and here. This one is NGC 2023, IC 432. So, it's coming up from all these different catalogs. This is the Flame Nebula. This is sort of a mix of the two phenomenon. So that covers the sort of emission and reflection nebula. The other one that we get are planetary nebula. So let's go back to the summertime sky again. And we're nearly done here with our little tour. Okay, come back to the Milky Way. So I'm going to take off the bright and hydrogen, and I'm going to put on planetary nebula. So planetary nebula, you can see, are scattered all over the place almost randomly. And planetary nebula are the corpses of stars that are medium or below average in mass, like our sun. And when the sun eventually comes to the end of its life, in about 4.5 billion years from now, the fusion in its core will cease, and that will cause the star to go through a complex process where it collapses under its own gravity and then eventually rebounds and blows off a shell of its outer atmosphere, leaving behind its core glowing as a hot white dwarf star. And you can see that because these objects, which are the green diamonds, are produced by just random stars that reach the end of their lives. And because our sun is one star in a three-dimensional volume of space, of stars all around us, then these stars can really be anywhere in the sky. They don't have to be limited to the plane of the Milky Way, because they really can be anywhere. And these all have really cool features in them. So let's see if I can find, here's the Cat's Eye Nebula. I center the Cat's Eye and zoom in on it. I'll just turn off the symbol for a second here so you can see it. Oops. So they can come in different shapes and sizes. I'm going to point out a couple of ones that you'll want to be keeping an eye out for.
While you're pointing these out, do you know the story of why they're called planetary nebulae?
Yes, because in a telescope, they show a little disk. In fact, let me show you the blinking planetary. So the blinking planetary is up near the wing of Cygnus. And in your telescope, it looks like a little disk.
Whoa.
And so people thought they reminded them of planets. And some of the planetary nebula are a little bit larger in size if they're closer, or they're smaller in size if they're farther away. This one happens to be 27 arc seconds by 24 arc seconds. Is sort of an oval shape. So this is, this could be comparable in size to Uranus or Neptune as viewed in a telescope. So one might easily get confused or confuse them for a planet, even though they're not.
But for those beginners out there, they have nothing to do with planets. They just look like them.
Resemble, yeah, just physically resemble. That's right. All right, so that's planetary nebula. Then you get supernova remnants. Supernova remnants are cool. There's a great one here. Just bring on the labels and markers. So Once we get to the summer months, and you can find Cygnus, which is a really easy constellation to recognize in the summer months. And if we're still broadcasting, we'll certainly tour this one in detail. If you look down below the star that represents the swan's chest, come down his wing by one star, two stars go back in between them and just go a little bit to the right, and you can find this large object. This object's called the Veil Nebula. And this is a remnant of a supernova that exploded, and the shock front of the gas, which is still expanding, has produced this sort of ragged, circular, remnant of the star that blew up. And this is actually huge. It measures 2 degrees 41 minutes. So that's almost 6 full moons across.
Wow.
Yeah. And this one's actually really easy to see in a backyard telescope, because if you've got a nice dark site, if you're at the cottage and you've got a moonless night, all you need to do is put this star, which is quite noticeable, 52 Cygni, in your telescope, and then start scanning around it. And if you've got a nebula filter for your telescope, you can make this nebula pop a little bit better. Once you've got this sort of mastered, then you can just manually sweep your telescope across and pick up the other bright arc on the other side. So that's a supernova remnant. The Crab Nebula, that Messier #1, that's also a supernova remnant. Right.
That one was one that actually was recorded by I think it was what,
1054.
Yeah. And it was recorded by Chinese astronomers.
That's right.
Yeah, that was really cool. That's something, this is what I really wish we would have sometime soon, please.
But not too close, not too close. All right, let's go back to tonight's sky, because we're just going to recap, a little bit about what we said the other day about the galaxies. So one of the questions that came up the other day was why there are different colored symbols for the galaxies.
Yeah.
And that's because there are different classes. So we've got the Virgo cluster of galaxies here. And again, I'm just going to wind this back just to make this a little less intimidating. But as I said, if you point your telescope halfway between Vendiamatrix and the Nebula, you're bound to pick up some galaxies. So we'll go in here, and I'll just draw some labels on here as well. And again, if you decide to make it your goal to see all the Messier objects, the 110 objects, this is one of the most challenging parts of that exercise, because there are lots of Messiers in this little patch. Whoa. So every one of the symbols and labels here are Messier objects now. So I've got about 20 of them or so. But it's actually not that bad, because if you have a nice star chart that shows which one's which, you just find one of these galaxies and then you just hop from next to next to next to next to next and make notes of them.
See, you say that's simple, but I'm still really bad at moving telescopes in a way, because they don't move logically when the picture, I find it very hard.
By the time you're done, you're an expert.
That's fair. That does. And actually, if it's okay with you, I may just briefly plug Rask's observing programs, because we have programs where you can go out and you can look for these objects, write them down, and document your observations, and you'll get pins for completing them. I haven't done any yet. I need to. But they're a really good way to receive something for the accomplishment of finding all this stuff. Yeah. So I'll send out the link for the observing programs in the chat.
And it really helps. By the time you're done, you'll know what a galaxy looks like in your telescope, and you'll be able to recognize them when they're there, and it becomes actually, not too hard to do once you've tried it for a while.
It is a good way to practice all this stuff, and a really great learning tool for even, getting used to using your telescope, that sort of thing. We have different levels of them, and it's also nice to receive certificates and accomplishments and pins for the things that you do.
Now, down here in this filter by type, you'll also notice that we've got other classes of galaxies. We've got active galaxies. And so the active galaxies are the orange ovals. And these would be the ones that have, maybe a radio source of a black hole inside them, something like that. So they don't necessarily physically look different through your telescope, but they're they can be distinguished by this other, other aspect of them. So that's the active ones. The interacting galaxies are the little blue ones. And when we talked about Markarian's chain the other day, just get into Markarian's chain here. And I pointed out the eyes, but they actually consider this pair, which you could almost call the eyes as well, as interacting galaxies, the two blue ones. So that explains what the different colors meant.
Thank you for finding the answer to that. I looked it up very quickly on Google and did not do a good job of finding the answer.
And clusters of galaxies, I mean, there are other parts of the sky that have neat clusters of galaxies, but I think, I would advise everybody to take advantage of the nicer weather, not maybe this week, but certainly next month. And, just try to hunt some galaxies down here in this patch between, Virgo, Leo, and Coma Berenices. And don't forget that there are always lots of galaxies kind of around the Big Dipper, which is the circumpolar constellation. So it's, it's higher, it's lower, but it's generally always available in the sky for you to check out. Now, the last thing I just promised that I'd do and I haven't done is talk about where the Caldwells are. Let me just turn these off and put on the Caldwell objects. And I'm not going to filter by type. So these are the Caldwell objects. And you can see that they're all over the sky. And really, from Canada, there's a limit to how many you can pick up. I think about 2/3 of them you can get, if you're patient and pick up the right, sort of week of the year to pick them up. But at some point, you've really got to go to the Southern Hemisphere. So Australia, South America, Africa.
I have a question just about some of the names that are up there. So I see. So you have the Ghost of Jupiter Nebula and stuff up there too. Those aren't Caldwell. Those are others.
No, these are all Caldwells.
Okay, so then my question stands.
Yeah. So if I go here to the view, to the option here, if I say use designations for screen labels, then these will all switch to Cs.
I see. Okay.
Yeah.
And so my follow-up question was, I don't ever remember hearing the Ghost of Jupiter Nebula as the name of something. Did he make up his own names, or are those standard names?
He may have. Jenna, I was showing you earlier a really great series of books called the Deep Sky Companion series, and they're written by Stephen J. O'Meara. And he is, if there's an astronomy superhero, it's him. He's got the most remarkable eyes on him. I don't know how he sees what he sees, but plus he also does observing from a mountaintop in Hawaii. So, I mean,
that makes things easier, doesn't it?
But he's written individual books on the Messier objects, the Caldwell objects, and then beyond. And he's got one that's Deep Sky Treasures, and the whole theme of the book is pirates and treasure. And so he'll coin nicknames for objects that are kind of pirate or not.
Oh, that's cute.
Theme. So that's fun to read his descriptions. Yeah. So if I turn off the Caldwells and put on the Messiers and just use the designation for screen labels, then you can now see where all the M's are. So what I'll leave you with in the last minute or two here is I gave you the homework of how to find some galaxies. And again, we've got another few nights before the moon starts coming back into the sky. One of the really pretty easy ones to spot is M3. M3 is one of those globular clusters. So where's M3 here? I'll just put this in the middle of the view. Zoom in, and I'll take off the symbol. So it's one of those neat globular clusters. It's quite bright. I saw it from my driveway in Thornhill a couple of weeks ago, and it was not hard to find. And that's something that you might even be able to pick up with binoculars. So if you just look, you'll remember, look for the star Arcturus, which is a really bright star in this area of the sky. And just scan with your binoculars about 1 fist diameter above Arcturus, and your binoculars will cover a good patch of sky, and you should be able to pick that up. So that's an easy Messier that you can pick up. And then later, we could look at Messier 13.
Oh, yeah.
It's one of everyone's favorite Messier objects because in a backyard telescope, it's so spectacular.
Wow.
And it's fairly bright. So it's pretty easy to pick up in binoculars and a backyard telescope. And I just want to bring up sort of in the summertime sky. Let me see if I can pick up the Ring Nebula.
Oh, the Ring Nebula is a cool one. Can you see that with, you need a telescope for that one, eh?
Yeah, so here's how you find the Ring Nebula. So once we get into the months, so this constellation of Lyra is up after midnight. It's getting high enough after midnight, but you know, by the time we get to June and July, this will be nice and high and easy in the sky. You look for Vega, the super bright star. Look for the parallelogram of the body of the constellation, and just point your telescope the best you can halfway between Chelyabinsk and Sulafat, and just zoom in on that spot exactly halfway between them, and you'll find this little donut.
That's adorable.
This is the Ring Nebula. So what you're seeing here is the former star, maybe similar to our sun, that exploded. The spherical bubble is the shell of gas that used to be the photosphere and the outer layers of the star. And then the little white dot in the middle is the core of the star, the white dwarf star that's cooling down. And its radiation is energizing the gas and giving it that color. So that's the Ring Nebula. And the other one that's a nice one for beginners is the Dumbbell Nebula. And let me just give us, here's the Dumbbell Nebula. Now this, remember, the Ring Nebula is sort of small and the Dumbbell Nebula is much bigger. It looks a bit like an apple core to me.
Oh yeah.
It's the same physics, but because of the way that the star explodes, gases can be thrown preferentially in different directions. And so we get a wide variety of sort of forms to these planetary nebulas.
Mm-hmm.
So just maybe note Dumbbell, Ring Nebula, M13, M3, these are the kind of things that you can start looking for as we get into the prime observing season. Any questions, Jenna?
So far, everyone's been, oh wait, we have a few more. These are less specific to nebulae. Is it okay to ask them anyway?
Yeah.
Okay. Alrighty, there's a big question, which we'll get to in a minute. Oh, do you know this? In the local group of galaxies, there is something called the zone of avoidance. Do you know what that is? I don't know much about our local group.
The zone of avoidance. Let's see.
So this comes along with other difficult questions about things that are in like deep space, like intergalactic space. Things like the Great Northern Wall, the Great Southern Wall, neither of which I've heard about, and the Great Attractor, which I have heard about. So I can explain the Great Attractor while you look up the zone of avoidance. The Great Attractor is an area of deep space that seems to be pulling things towards it. We don't know what's there. We can't see what's there. It's probably like a mass of galaxies, something like that. So it's pulling stuff towards it, which sounds ominous, but it's really not. There's lots of gravity out there.
All right, so if I'm right, if this is what the questioner means. So when Herschel was scanning the sky, he was noting differences in the ways or the distribution of types of objects in the sky. And as I mentioned on Tuesday, if you want to look at galaxies, you're not going to find any near the Milky Way because they're actually blocked by our own galaxy. There are lots of them out there. And so if you actually plotted a map in three-dimensional space of where we know all the galaxies are in the universe, there's actually there's a gap in that map because we simply can't map the positions of galaxies that we can't observe because they're obscured by our own Milky Way. And so there was a time when that was considered a zone of avoidance, where there was, why are there no galaxies in this part of the sky? It's because they didn't understand that they were there. They just couldn't see them because of the nature of them. They weren't possible to be seen if they were farther away than the dust and gas of our Milky Way.
Just stuff in the way. All this stuff out there.
Now, if a galaxy is giving off radio, then we can see it. So we do know of galaxies hiding behind our Milky Way that are radio sources.
Yes, that is true. Okay. This question was just briefly answered by a couple people, sort of, but maybe you can expand on it a little bit. Are planetary nebulae where new planets form?
No. So the planetary nebula would be the end of the solar system rather than the beginning of the solar system. So again, it's one of those unfortunate uses of terminology. So planetary nebulas don't have anything to do with planets, just like, you know, we call it dark matter, not because it's necessarily dark, but because it's unknown. So, you know, perhaps it'd be nicer if they had another name for it, but that's what they reminded people of. So that name stuck, planetary.
Yeah, for sure. Nothing. So stars and planets form typically in other types of nebulae, star forming nebulae, where there's enough dust and gas to like pull together instead of the dust and gas going poof.
Yeah, well, but now we think that in all likelihood, when stars coalesce or condense out of a hydrogen gas cloud, that planets are also condensing too.
Mm-hmm.
So they're forming with planets around them.
So there's okay, I'm having a little bit of trouble keeping up with the questions. Nope, we're good. We're all good in the chat. Okay, so there's a question which we can do a little shout out to next session about, is there a type of book or beginner website or guide that has a list of best things to look for as a beginner? So like having this knowledge of M13, M3, Dumbbell Nebula are good beginner targets. And we are going to go over some apps and tools. Chris, do you know anything off the top of your head that would be a good start for that stuff?
Well, if you get a basic, if you want to buy a book, actually, let me just turn off my, I'm just going to turn off my virtual background here so I can show you.
Also, while Chris is away, Colleen pointed out as well that the Observer's Handbook is a good tool for that. And that's this. So this has a bunch of targets in there and you can kind of go through. It's a big book, but it's got a lot of information. Back to you, Chris.
The Observer's Handbook has a section at the back called the Deep Sky. And it lists a selection of deep sky objects that are brighter, selections that are closer. It has the best star clusters. It has Messier list, the Messier catalog, and descriptions on those. So that's a resource. If you get yourself a star atlas, this is a good beginner one, basic one. It's not a beginner one. It's a good basic one that a lot of people have that getting into astronomy. And you'll see that just like Stellarium does, that the star maps have colored symbols when there are nebulas or star clusters, and the Messier objects would be indicated as M objects. Then you can find yourself, there's lots of astronomy books where people have listed their favorite objects for each constellation. Here's one that I've used, Objects in the Heavens. It's not a very thick book, but it sort of goes through and gives you kind of the best, the best things to see in a particular constellation, including double stars and nebulas and galaxies and so on. But yeah, we can devote a session on things like that in a future.
Yes, and we also, even while you were talking, we got a bunch of suggestions in the comments. And so things like Night Watch, Explore the Universe, which is a book, and Sky News Magazine are all really great resources. We also had a question just while you have your books out, that first book, the Messier book, where it goes through the history of that. Do you have that with you? And do you remember what the author's name was?
Yeah.
Sorry to make you keep walking back and forth to your bookshelf.
These books make excellent birthday and Christmas gifts. because in Canada anyway, we have a lot of cloudy nights, that there's a lot of really good reading in these books. So they open up, this is Stephen O'Meara, opens up generally with a chapter, a historical overview of the, in this case, Charles Messier. I've got one here on the Caldwell objects, and then the one about, I think the one about buried treasure had Carolyn Herschel or John Herschel in that one, or William Herschel. So this one's great. So what he does is he gives you a good write-up on every Messier object. He gives you tips on how to find it, star hopping. He gives you the current astrophysical explanation for what the object is, and he gives you some historical perspective on, you know, how he felt about how it got discovered, and maybe some color on that as well. So these are great books to sit and enjoy on a night when you can't have the telescope outside.
Perfect. I'm also going to throw out just in the chat a link to a beginner observing list, which is like sort of a bit of a guide to help out with some of our observing programs put together by the Regina RESC Center. I've seen it and it's great. So that's a good place if you're looking for a good start. I haven't checked YouTube in a while, so let me go back and see if there's any questions there. But I think we've covered most of them. Yes, we have. Okay, so then I have one last question because it's 4:30. And this one's a little off topic, but it's kind of cool. You and Randy Atwood were consulted on the technical details of Canada Post's Apollo 11 stamps. Did you spot any technical errors?
I wasn't.
Oh, you know what it was? Sorry, that's a slightly different question. I can actually answer some of that. That's Chris Gaynor. Chris Gaynor is the president of the RESC. Sorry,
another Chris. You know, there's the Dave's Club in the RASC, but there are also some Chris's too.
There's a lot of Chris's. I think I remember a couple things. So Randy I used to be in contact with Randy quite a bit, and he had mentioned that there were certain things that were wrong. It was something to do with the position of the LEM and its relation to the moon or something like that. They rearranged it so that the LEM looked like it was landing on the moon, and the CSM, the command service module, looked like it was going back to Earth. So they put a lot of thought into it. He's got some details on that. I'm sorry we can't answer it in more detail. I'll ask Randy if he can maybe summarize that, and I'll post it somewhere online. We'll see if we can get you an answer for that, Bruce. It's a neat one. Alrighty, I think that we have covered all the questions. We've actually ended on time, I think, for the first time in this series. It's just because you guys like questions so much, and we have so many cool things, and there's so much to learn. Chris, did you want to throw any last minute things out there, or are you all happy?
Just that you mentioned on Tuesday that we're going to rethink our format. So we'll do a little bit of what's happening in the sky. We'll go 90 minutes instead of 60, and then we'll leave lots of time for questions at the end.
Yes, and there was a question that I forgot. So yeah, just make sure that you sign up so we're now doing once a week, 90 minutes. Make sure that you sign up for them starting on Tuesday next week, as they weren't included in the original registration list. So make sure you register for those. One last question. There was a question about finding Comet Atlas, and I think we've mostly answered it in terms of make sure that you have the most recent Stellarium downloaded, and make sure that you're looking for not just the words Comet Atlas, that you're looking for its proper name, which is C/2019 Y4. What a great name. So just make sure that you use those details specifically. And
you know how those names come about?
How's that?
So the C means it's a comet, a P means it's a periodic comet, and then the /year, and then the Y4. So they take the alphabet, and every 2 weeks of the year it's another letter. So A1 would be the first comet discovered in the first 2 weeks of the year, and Y4 would be the fourth comet discovered in the October, whenever it was. You do the arithmetic. And then the Atlas comes from the person or robotic observatory that discovery.
Oh my goodness.
So Pan-STARRS or Atlas or maybe it's Lovejoy, or maybe it's Levy, after David Levy, the Canadian comet hunter extraordinaire.
Absolutely. Perfect. Thank you for that information. Thanks everybody for joining us. Next week we're talking about apps and tools, right?
Yep.
So we're going to go over apps and tools that you can use to help observe. Join us for that. Lots of questions on that. So we'll cover a lot of those next week, and we'll see you then.
Bye for now. Keep looking up.
Bye for now. See you guys.